A very good morning to all. Today we are going to discuss about what is a corrosion and what are the factors influence on a corrosion. Let us see what is corrosion. Corrosion means the process of decay of metal by environmental attack. The process of decay of metal. That means if you are taking any metal, that metal will be formed as metal will be converted into metal oxide. This is known as a corrosion. So for any metal, if you consider like iron or zinc or copper, everything will become as metal oxides, and these are the known as, this phenomena is known as corrosion. Why this is happen in nature? Because pure metal is less stable. This metal oxide is more stable. In nature, metal oxides are more stable than pure metals. That's why all the metals available in ores as a metal oxide form. So that's why after extraction in a metallurgical process, that metal naturally change into metal oxide form. This phenomena we consider as a corrosion, and that product is known as rust. The process is known as corrosion and the product is known as rust. And now what are the disadvantages of the corrosion? So the major disadvantages, the main physical properties of metal will be vanish when it changes into metal oxides. The properties like conductivity and ductility and strength and malleability will be lost due to corrosion. And also the wastage of the metal also harmful for infrastructures. That means the metal like iron which is used in constructions, after corrosion this iron lost its strength as a form of iron oxide, that infrastructure got damages or collapse due to this corrosion formation. And the overall wastage happen throughout the world on the production is around 1/4 of is the production. That means on a particular year, if they produce 100 tons of a metal during metallurgical process, out of 100 tons, 25 tons will be wasted due to corrosion. And this is also leads to decrease the lifespan of the metallic parts. That means this corrosion leads to damage of a metal in a various ways. And this corrosion we classified into two types. One is dry corrosion, another one is wet corrosion. The dry corrosion means because of gases. This dry corrosion we consider for due to gases, and wet corrosion due to moisture or acid medium or salt solution. Acid medium or salt solution. So in this way we classify this corrosion in two ways. Now see what are the factors influencing on this corrosion. The first part of the factors influencing here is about nature of metal. How this metallic nature influenced by corrosion, let us see. This first point is position of a metal in a galvanic series. Position of a metal in a galvanic series. So what is the meaning of a galvanic series? Galvanic series explains about position of metal which is treated with seawater. That means here initially first they consider a metal, and that metal is dipped in a 1 liter of seawater. Then they identify the extension of corrosion happen on that metal. According to that, they give a position of a metal or metal alloys in the series table. That means in a galvanic series, topmost position metals shows more corrosion. If the metal exists at the bottom level, it shows less corrosion. Like that, this galvanic series is formed like from sodium, calcium and zinc and so on. It will be ended with platinum and gold and platinum, silver and gold. It is ended with the platinum, silver and gold metals. So these are shows more corrosion and this part shows no corrosion. These things are doesn't show any type of corrosion. So that is the first point. That means if any metal exists at the bottom of the series, then it shows more corrosion. If it exists in the bottom level, it shows less corrosion. And coming to the second point, that is about over voltage. If any metal we consider on oxidation, if it produces M plus, in presence of H plus, it produces hydrogen gas. So then that is known as evolution of hydrogen process is more, corrosion also more. That means in a over voltage process, hydrogen gas liberation will be excess thing will be happen. That means hydrogen gas evolution is going more and more in corrosion processed metals. That means this over voltage increases, corrosion increases. And coming to the third point, relative areas of cathodic and anodic areas. There is a small relation between anodic and cathodic areas of a particular sample. Let us take one example. Suppose in a classroom which has 50 benches are available there and 40 students stay outside of the classroom. That means 50 benches are there, 15 persons can be seated in a classroom, 40 persons are ready to occupy that room. So what is the speed of the students to occupy that place? It is fast. That means more space is available, less number of students, so that they can easily sit in a classroom. And now consider this example in a reverse way. That means in that classroom only contains 20 seating capacity and outside 40 members are waiting. So when they are entering into the classroom, only 20 members can be seated. That remaining 20 members are, they don't have any place there. So like that, we take here example like that way for a relative areas of the anode and cathode parts. That means in general corrosion happens moving from anode to cathode. Electrons will be moving from anode to cathode. In a previous example, if students are like an electrons, so that they are moving from anode to cathode. So in first case, 40 students and seating capacity is 60. That means low anodic area, more cathodic area indicates high corrosion. Corrosion will be high. If it contains low anodic area and more cathodic area, that indicates it shows more corrosion. Like a second example, if this anodic area is high and coming to the cathodic area is low, in this case we observe a low corrosion process. So relative areas indicates that this is the condition required for control the corrosion. That means for any material, if it contains high anodic area and low cathodic area indicates less corrosion. And next one, purity of the metal. That means 99.9% pure metals can produce, that means they doesn't produce any type of corrosion. That means impurities doesn't influence that corrosion process on metals. And next one, physical state of the metal. That means how it will be appear, that metal oxides, how it will be appear. Physical state of metal oxides can be considered here. So if the physical state is volatile, we observe more corrosion. If it is stable, we observe less corrosion. And also similarly for nature of surface film. So surface film here we consider in a 4 ways. The first one is stable layer, and second one is unstable, and third one is volatile, and fourth one is porous. So 4 types of oxide layers can be considered, how the corrosion can be going on. First, if you consider the stable oxide layer, that is a surface film happened. So let us take example like a metallic surface with a shade, and this is the metal oxide and this is the pure metal form. Suppose this metal oxide is formed stable way. That means it doesn't allow any oxygen. It doesn't allow any oxygen on the next layer of the metal. That means this stable oxide layer stops the corrosion. Whereas coming to the second case, in the, like an unstable layer, so this layer again converts into pure form of the layer. This metal oxide is forming and again it converted into metal form. So metal oxide formed outadi and again it will be converted as a metal. This is the unstable nature. In this case, we doesn't observe any type of corrosion. And coming to the third case about a volatile film, that means it will be evaporated when that metal reacts with the oxygen in air. That metal oxide formed is evaporated with the atmospheric temperature. So that every time this process is going on, after some extension of time, entire metal will be evaporated. So volatile oxide films also shows more corrosion in the metals. And coming to the fourth one about porous materials. This porous material means this metal oxide film will be as some pores. It has some pores on the surface. These pores allow the atmospheric oxygen into the fresh layer of a metal. So this is also reason to increase a corrosion. Now let us see what are the metals examples for these oxide layers for stable, unstable, volatile and porous. And for this we can consider iron, and for this one we consider a silver, and for this one we consider a molybdenum, and this is for a sodium, and this is for a sodium. Like that we can take examples of different oxide film layers. And next one, passive character. Passive character means which are not show corrosion. Like previously saying from the galvanic series, these three metals are known as passive metals. These three we consider as a passive metals. So passive character means which are not forming metal oxides. They are stable in metal forms, not in metal oxide form. And next one, volatility of the thing. So what we mentioned here, this is the thing about volatility. And next one, solubility of the corrosion product in a medium. So like this type of metal oxide is starting to soluble in acid or any salt medium. So again fresh layer will be ready to participate with the reaction with oxygen. So that if metal oxide dissolved, the fresh layer of metal ready to react with oxygen, and it allows to further corrosion. If the solubility of that corrosion product increases, corrosion also increases. So all these 9 points influencing about nature of the metal. And the same way, environment also plays some crucial role. That means if a student wants to be ideal, not only happen by himself, the surrounding people also help him to become an ideal person. That means environment also plays a role on a person how to react. The same way on metals also, the surrounding environment plays or influence the enhancement of the rate of corrosion. So now let us see factors influencing on the corroding environment. What are the things is existing there to improve this corroding environment? The first point is temperature. As all of you know that rate of a reaction directly proportional to the temperature of the reaction. That means rate increases when increase the temperature. That means corrosion also one type of a reaction, that is the oxidation reaction. So that temperature increases, corrosion increases. So in this case we understand that temperature increases, corrosion also increases. And coming to the second one, humidity. This humidity we observe in mainly in wet corrosion. Mainly in wet corrosion. That humidity is nothing but here moisture. So let us take one example. One iron statue is established near the seashore and one is at a hill area. So which iron statue shows more corrosion. Near the seashore, iron statue shows more corrosion because of the moisture or humidity exists on that environment. So, when the moisture increases, that indicates that humidity also increases, so that this wet corrosion will be happen. And after that, presence of impurities in atmospheric conditions. This environment impurities, like we can consider salts or acids or gases. So here we can consider salts or acids or gases as an impurities. These are also enhance the rate of corrosion. And next one, nature of ions present in the medium. This is also we observe in wet corrosion. So where we observe that mobility of the ions increases, corrosion increases. Corrosion increases. And next one is conductance of corroding medium. That means this conductance helps to again mobility of the ions. This conductance is more in acidic medium and salt medium, so that here also it helps to increase the corrosion. And next one, amount of oxygen in atmosphere, that is also influence the rate of corrosion. How excess amount of oxygen causes to the more corrosion. And next one, velocity of ions in the medium. Like this point is interlinked with this conductance of the corroding medium. So if conductance is more, conductance of a solution is more, velocity also increases. Velocity of ions also increases. When both are increases, the rate of corrosion increases, so that this velocity of ions in a flow of a conducting or corroding medium also increases the rate of corrosion. And final thing is about pH value of the medium. In general, less pH value indicates more corrosion. Less pH value indicates more corrosion. That's why in acidic mediums we observe more corrosion. In acidic medium we observe more corrosion because of the pH of less values. So less than 4 is more acidic medium, so that on that region we observe a more corrosion. So in this session we discussed about two things. First point is what is corrosion and what are the disadvantages of that corrosion. And a second point is what are the factors influencing on corrosion. In these factors we classified into two types, nature of metal and the nature of environment. So that's it for today's session. Thank you.